3, 2, 1. So the way this is going to work is that I'm going to present lecture to you in this format, where I'm basically going to take PowerPoint slides and kind of march through them, telling you what I think is important, or you know. So for instance, what I'd like to do first is to talk in general about what is physical science, because the name of this class is Exploring Physical Science. So we can see that actually, and there's different hallmarks of science. What is a science? We'll talk more about what that is. I bet you already have your own idea, but there's formal science, natural science, and humanistic science. Formal science is your math, etc. Natural science, then we have physical science broken out of there, and you're going to see actually this idea of when we come to natural science, it breaks out into physical science versus biological science. And we'll have another slide to kind of say what those are. We also, science can be our behavioral sciences, our social sciences. So again, this is just another kind of screenshot of, or a figure of how we can break out science. If we go over here into our natural sciences, again, we have physical and biological science. And now we kind of have the breakout into the different physical sciences, as I think of them anyway. That's why I chose this figure. Physical sciences involve chemistry, which is what my degree is in, physics, astronomy, and earth science. And we're also in this course, of course, going to talk about weather or atmospheric science. So just again, what do we mean by sciences? There on the left, we have social sciences. On the right, we have our natural sciences. Very quickly, they break out into physical science or biological science. I have a bias. It's not really a bias, but I think that if you go into a physical science, you think a little bit differently than if you go into a biological science. That's just my perception. So again, we have physical sciences broken out into physics, chemistry, astronomy, meteorology, and earth science. So there you go. Again, another figure kind of showing you the flow of science. Some would say there was this debate, I know, for high school students when they come to take science, and you know that they need to get biology, chemistry, and physics under their belt. What do they take first? And oftentimes, actually, it is the science of physics from which chemistry comes, and it is the science of chemistry from which biology generally comes. So that's kind of what this is emphasizing. So I also want to, in your textbook talks about this concept of the scientific method, and you've probably already been exposed to what the scientific method is, but just to kind of emphasize, let's see if there are kind of some things here. The scientific method is the what makes sense method of thinking through things. Science always needs to be based upon observations, and that's where scientists start. So based upon observations, we kind of ask a probing question. I think when everybody grows up, whatever grows up is, we should all end up in a job that we enjoy doing. And I think many people find science rewarding. Maybe you might be one of those. But my point here is that we start with what you see. We ask a probing question, maybe something that interests you. That was my point about science. I'm not the only, that science piques a lot of people's interest. And then based upon maybe what else you know about the phenomenon that you're observing, you come up with a hypothesis. Okay, you come up, sometimes hypothesis is called your best guess. And your best guess, your hypothesis is kind of it's in process, okay? And ideas, scientific ideas will stay a hypothesis for a relatively long time sometimes, gathering more observations, looking at it different ways. One of the things about scientific concepts is we need to be able to use scientific concepts to make predictions of the way natural phenomenon behave. So And that's kind of what we're after when we're using the scientific method. So we make a hypothesis, and then you're back to the lab or back to gathering observations and refining your hypothesis. And I kind of tease that scientists are a bunch of like little kids, in that scientists all like to kind of poke holes in other scientists' scientific ideas. And so when you put something forward to the scientific community, your peers, it's wrestled with. So that's just kind of the way it goes. And it's a beautiful part of the scientific method, I think. But the deal is if you have a hypothesis that undergoes your own scrutiny and the scrutiny of the scientific community to which you belong, and it stands up to that scrutiny and it continues to be reinforced, then that hypothesis can be elevated to what's called a scientific theory. Okay? So one of the things I want you to get out of this is there's a big difference between a scientific hypothesis, which is a best guess and kind of a working sort of thing, and the real deal scientific theory. So this is just another flow chart. Let's see if we can kind of see the similar elements. You ask a question, you do your research, you come up with your best guess or hypothesis, you do testing, and is your hypothesis true? Well, great. Then go ahead and have your friends try to poke holes in it. Are there some issues with your hypothesis? Well, then go back to not necessarily the drawing board, but go ahead and tweak your hypothesis. So here is just another way, and I think this might be a figure from your textbook that talks about the scientific method. And again, you'll see the things that we've been talking about, observations, come up with a hypothesis, use your hypothesis to then make predictions based upon what you believe the situation to be, and then test those predictions come out. More observation. Okay. So I kind of look at the term theory in the scientific method as playing checkers, okay? So if you're playing checkers, your goal is to get from your side over to your opponent's side. And of course, if you do get to your opponent's side, clear to the other side of the checkerboard, they king you. And see, to me, that's what a scientific theory is it's basically a hypothesis that has made it through, and it's the real deal. It's scientific theory. So one of my pet peeves is when I hear in the news or whatever, just people in general say, well, it's just a theory. And I've probably said it myself. But if it's a theory that's undergone the scrutiny of the scientific method, then it's a big, hairy deal. This is another flow chart of kind of looking, this also might be from your textbook, what do we mean by the scientific method? Again, we have observations and measurements. Oftentimes in science, and we'll be doing this in this class, we need to talk specific quantities, numbers, and units, okay? Then from observations, we come up with a best guess. That's a hypothesis, but we're not done yet. Then there needs to be more experimentation. It kind of goes back and forth, those first three. And then after extensive testing, your hypothesis can be elevated to a theory. Now, the difference between, I just read this recently, so I'm kind of excited. The difference between a scientific theory and a scientific law is that the scientific law has taken it one step further, or a scientific law can take a scientific theory one step further and quantify the scientific principle. For instance, the law of gravity, okay? Newton's law of gravitation. That, we'll talk more about this, but gravity is something we're a little bit familiar with. You drop a pencil, and for the attraction of the mass of this pencil, when the mass of the Earth will cause the pencil to fall to the Earth. That's gravity doing its thing. And not only is that observable, but it's observable and can be quantified. So that gives us a scientific law.